Hey everybody, Paul Dietrich here, and welcome to the third video of this three-part series of solving systems of equations. This third video is solving a system by the third and final method, which is substitution. In the first video, we covered solving a system by elimination. The second video, we covered solving systems by graphing, and now we are into the last and final method, which is substitution. So, what is substitution? It's not as bad as you think. Substitution is kind of like, well, let's say you have a substitute teacher, right? So let's say if I'm gone, if I'm not in the classroom, and I have a substitute teacher come in, well, that teacher is there to replace me, right? So that kind of same idea is going to be applied to what we see here on our example. What we're going to be doing when solving a system with substitution is we're going to be replacing a value or replacing something with something else. So let's actually take a look at the problem here. Now, if you notice in our system, I have two different colors, and these two equations are written not in the same way. This first equation is written in slope-intercept form, and this second equation is not, right? So if we wanted to solve this by graphing, we'd have to rearrange this bottom one. Solving the system by elimination, we'd have to also do a little bit of rearranging. But what's nice about substitution is if we run into a situation like this, where we already have one variable all by itself, and it's isolated, right? Y equals this. What we can do is actually substitute this value for y and substitute it into this y in the second equation. So what I mean by that is I want to take this value for y, which is 6x minus 11, and I'm basically going to put it in here into this y. Because if y equals this, 6x minus 11, then this y, which has to have the same value, also equals 6x minus 11. So let me just rewrite that. Let me show you what I mean here. The line through here. Okay. All right, so I'm just going to rewrite this second equation. So this second equation looks like this. Negative 2x minus 3. Now, instead of saying 3y, I know what y is. Y is 6x minus 11. So, inside these parentheses, I'm going to have 6x minus 11. I'm going to complete out the equation. Equals negative 7. Okay, so just to do a quick compare. This second equation, I just rewrote it. I substituted 6x minus 11 into here, into this y. I rewrote the second equation, and now it looks like this, right? So instead of saying a minus 3y, well, it's minus 3 times 6x minus 11. Okay, now what's nice about the second equation, and this is the whole idea behind this, is if you look at the second equation, there's only one variable. It's just x. We don't have a y anymore, right? So I can just solve for x. So let's go ahead and do that. I'm just going to rewrite this because this guy didn't do anything here. So this is negative 2x. And now we kind of get into this part. We always look, kind of following your order of operations, we always look what's inside the parentheses first. 6x minus 11, those are not like terms. So I have to look at this minus 3 on the outside, it's negative 3, and distribute. So I'm going to take this guy here and distribute to every single element inside the parentheses. So negative 3 times a positive 6x, well, that's a minus 18x. Negative 3 times a negative 11, that's a positive 33 equals a negative 7. And now what I can see is this. I actually have like terms in this equation. So this negative 2x and this negative 18x, I can combine those. So when I combine those, negative 2 minus 18, this is negative 20x. All right, still got my positive 33 over here. This still equals a negative 7. All right, there you go. I want to get x by itself. What I want to do is I want to get rid of this positive 33. So I'm going to minus 33 on both sides. There. Okay. These 33s cancel. And then here's what I got left. This negative 20x equals, now negative 7 plus a negative 33 is a negative 40. Okay, I got a negative 20x equals a negative 40. I'm going to divide both sides because these guys are being multiplied to each other. I'm going to divide by the number I want to get rid of, which is at negative 20. Those guys cancel, right? On my last step here. Okay, so we have x equals, now a negative divided by a negative, that's a positive. 40 divided by 20, that's 2. So x equals 2. Okay, now this seems like a lot. So, I mean, it was a lot of steps in the but now here's the thing. It's kind of like you're saying, okay, Paul, we just got through this entire piece of work right here, and we only have one variable. Are you telling me we're going to have to do that same amount of work just to find y? The answer is no. Y, the second variable, is actually way easier to find once you have the first one. So now that we have x, all we're going to do is plug it into one of the original equations to find y. And you can probably guess which equation I'm going to plug this into, and it's that first one. That's the smallest one. It's the easiest looking one, and y is already isolated by itself. So I'm just going to do, let me draw a little wall here. Like this. Okay, now I'm going to write out that first equation again. Y equals 6x minus 11. Now, here's the deal. It says 6x minus 11, but I know what x is. X is 2. Now, this is what it looks like. Y equals 6 times 2 minus 11. So y equals 12. 6 times 2 is 12 minus 11. And y equals 1. Now, it could also just be much, much shorter than this. I just wrote down every single step. You can see, oh, you could just normally just say, oh, well, 6 times 2 is 12. 12 minus 11 is 1. And you can go basically here all the way straight down to this line if you wanted to. But basically, that's it. So just to kind of recap, what we did is that given a system, we wanted to solve by substitution. So what we did is that we substituted the very first equation into the second one, right? We substituted this y into this y here, the second equation. We actually simplified and solved it all the way to the bottom to where we actually solved for x. We got x equals 2. And then once we found x, we could plug this value into the very first equation to find out what y is. So that's it. That's substitution. So we just found both x and y through substitution. So I hope this video series was helpful to you. Please comment in the section below. I'm more than happy to answer any questions. If there's anything I can prove, I'm looking forward to those too. But thank you very much, and look forward to the next and upcoming videos.